Hi, my name is Mehmet, and I'm from TU Delft. I will present our work, Speed-Modulated Ironing. So these days, with 3D printing, when we need more properties, we just add more materials in the mix. But this comes with certain challenges, such as like complex hardware or bonding issues between materials and sustainability, obviously. And so our question is, how can we achieve more properties from one single material? So commercial solutions now are all with multiple filaments, so for instance, using multiple nozzles or tool changer systems, or switching materials, and, or prefusing the filaments. Alternatively, there are adapted slicing and printing strategies, such as pre-programming the filament or creating 3D hatching with contrasting two materials. And these are still multi-material solutions. And there's also velocity painting. It is a single material solution, but with limited texture changes. And a promising direction with a single material is using the temperature response of the material. For instance, the expendables or the 3D printed pyrography. In these works, the way of changing the texture is with the nozzle temperature. But the nozzle temperature changes are slow. And so this creates the challenge of creating fine details or gradients of the texture. So our goal is to create high resolution and continuous textures using this temperature response of the materials. Since the 3D printer is not good at changing the temperature rapidly, but it's still good at positioning and changing the speed rapidly. So we use the speed to regulate the amount of heat we put into the material and to activate it. So in speed modulated ironing, we use a standard dual nozzle printer. With the first nozzle, it is just regular printing at a relatively lower temperature. But with the second nozzle, it's an empty one. We use it to iron the printed layers and thus activate the material. So this allows us to control the heat transfer precisely, and this way we can also control the texture the same way. So that is the novelty we are proposing here. We use three materials in this work. One is foaming PLA, and so this material, with the increasing heat, it expands and also gets lighter. And then we have wood fill and cork fill. And then in these ones, they get darker as the heat increases. So pyrolysis is the way of changing the texture in these cases. And so with the changing speed, we can change the appearance or the property of the material, but then the question is how the ironing speed affects the temperature. So for this, we use the 1D conduction model to get the correlation between the ironing speed and the temperature of the ironed segment. And here we have an example of this correlation. And here you see the nonlinear correlation between the temperature and the ironing speed. And this is the core information we use in our work to modulate the ironing speed. And then our next question is like how the ironing speed affects the color shade. So for this, we measured using the delta E and to measure the color difference relative to a reference region. So the reference region is not ironed. And then we obtained a similar graph between the color change and the ironing speed. And when we overlap this with the first graph, here you see like they are largely overlapping. So the temperature and the color change are quite proportional. So based on this information, we built our workflow. We start with a 3D model with a texture, and then we just slice it regularly. And then after slicing, we get the 3MF and the G-code files, and then also we use the the initial OBJ and the texture image, and we use these inputs in our tool, and this tool converts these into ironing toolpaths. And looking closer to our tool, so we get the input G code, and then we extract the outer wall from the G code, and then we use that to create ironing paths. And then we divide that ironing path into sampling points. So for instance, we use 0.2 millimeter distance between the sampling points. And then using the texture image, we assign colors to these sampling points. And then using the graphs that I showed before, we convert the color information of the points to varying speeds. And then we obtain the G code for ironing, and then we merge it with the initial G code, and we have the final G code for printing. So here's our tool. In this tool, we have some predefined settings for the materials that we tested, but it's also possible to use the advanced settings for changing those. And then we have two modes of input. One is image projection and the textured OBJ. And then you choose the directory, which includes all the input files. And then when you choose the texture image, so that applies it to the, yes. And then when we generate the G code finally, here you'll see the toolpaths. And in this close-up, you see the color of the segments. So these segments colors also, they correspond to the ironing speed. And here is the final 3D printed part. To evaluate the capability of our methods, we used these four images to test the contrast and the continuous gradients and the feature details that we can achieve. And here you can see, so we achieved quite sufficient detail and contrast for working QR codes, and we obtained continuous gradients. And of course, there are still some improvements needed for thin lines for wood fill, for instance. And we also checked for the text legibility, and here we have a sample 50 by 100, and the smallest readable font for the foaming PLA, it's 9 points, and it's larger for wood fill and cork fill. So coming to the applications, so the most evident one is the color shade. We can use this for putting basically any image on the 3D printed objects, or we can also use it to print 3D scans, for instance, with varying color shade textures. And then we have also other texture differences, such as the gloss or the roughness. So we can use this for grip surfaces or touch interfaces. And a particular application is the translucency. So this is just specific to the natural color foaming PLA. So in this one, we can have varying translucency, which can be used for, such as these bottles. And coming to towards the end, so in this work, we just worked on the outer walls. So interior geometry is something to work on in the future. And related to that, going beyond the visual properties, which requires actually also working on the interior geometry. So it's possible to explore further properties like mechanical properties. And another point to explore in the future is specialized materials for the process. I think we can explore further what materials are best for this process, or if we can develop new materials or tune the materials to have better results with this process. So in conclusion, with speed-modulated ironing, we achieve continuous and high-resolution details in color, shade, texture, and transparency. And we believe that it's a step towards increasing range of properties while reducing the number of materials used. And finally, I'd like to thank to all the co-authors in TU Delft and MIT. And thank you for listening.
Question? Had a quick question. I noticed you need two nozzles for this method, but sounds like it might be possible to do with single nozzle?
There are several problems with that. One is the material degrades inside because the ironing nozzle is at a quite high temperature, like it's around 300. So, and also you would have defects on the print that way. So you could, you could retract, but that doesn't really work.
Yeah, makes sense.
Ken was faster than me. I was going to ask that, and I had a follow-up question, which was, some filaments can function well with higher temperatures, so you could have more than two colors. Have you considered that? So you would, because you already have two head printers. Did you try that?
You mean using two materials?
Yeah, two filaments, and one of them would have a fairly high temperature.
But high printing temperature.
Yeah.
And then using that for both ironing and then maybe. But still, you would contaminate the print, I guess, like where you don't. Yeah.
Okay, just an idea.
It could be. Maybe, I'm not sure. Maybe it would work. Yeah.
Okay.
Yeah.
Thank you.
Hello, I'm Jaji from MIT CCL. So it's really inspiring that you could try to ironing the material to have a different property with another nozzle. Have you ever think about using other kind of manipulation with a nozzle, like reshaping the things or subject things, could combine additive manufacture and subjective manufacture together for some new properties? Is that achievable? Have you any kind of future innovations on this?
Well, we didn't actually think about that. I mean, we didn't think about really manipulating the geometry with the second nozzle. So it was really focused on without altering the geometry, but altering the properties. So I mean, it could be possible maybe, but we haven't really checked that.
Okay. Yeah. Thank you.
Thanks.
I noticed that the second nozzle, the ironing nozzle, was of a distance of 0 millimeters to actually press against the layer that had just been printed. Do you ever get material buildup in that second nozzle as a result of it pressing up against the piece?
So it is kind of, not exactly pressing. So it is at the, kind of right on the surface, but so not really. We didn't have that much material buildup.
So you didn't consider closing the tip of the nozzle with anything, but just it worked fine just with an off-the-shelf?
Yeah, I mean, it worked fine, but also after a while the nozzle was clogged anyways, so it was, it was blocked.
Thank you.
Hi, I have a question regarding the texture part. So when you print, when you iron it and the texture appears, right? Does it affect the further layers? Or also another question is a bit about the angles. So all the examples you show are kind of curved, and I was wondering when you iron it on an angle, when you extrude, usually there can be I forgot how we called it, too much material. But when you iron it, maybe the temperature is there for a little bit longer than when you go on a straight path. So I wonder if you encountered any issues with.
Yes, indeed. If you're if it is at the lowest ironing temperature and if it's on a corner, sometimes that creates problems because indeed it gets slower. So there's something actually to take into account later on. And what was the first question?
The layering. So when you make the texture, does it the layers further?
So the previous layers, right?
Yeah.
So actually that was in one of the graphs. When you go further down, it doesn't affect that much the layers below because of that distance. Yeah.
Okay. Thank you. Very cool. Yeah.
Thanks.
Very cool. Do you happen to have that sample with you right now?
Yeah, we have a lot of samples, so you can come and check.
Yes. For all papers, please come to front after the talk. I hope everyone. I don't know if all the authors have it, but you can talk about it. You can test the prototype, and you can enjoy chatting with everyone. But with that, let's thank